whatever you'd like to call them. So with us today is Erik Runyon, who's going to be talking about how we can take the web offline. So please welcome Erik Runyon.
Thank you, Stephen. I'd also like to start off by thanking the conference organizers. It's a privilege to be here. To be very forthright, this is my first time in Europe. So I've really enjoyed the past couple of days. I've had time to walk around and see your city, and it's absolutely beautiful. You've made a great first impression. So, like you mentioned, my name is Erik Runyon. I'm from the University of Notre Dame, which is in America. It's not this Notre Dame. It's actually this Notre Dame, which was founded in 1842. Now, this building is not that old. This is the third version of this building because the original one burnt down. They built a new one, it burnt down again. So, I mean, as far as old architecture goes, it has nothing compared to what you guys have here, and it's pretty exciting. So, all of the links that you're going to see on the slides throughout this presentation are available at that URL. There's also the description of the talk, and there's also a link to some source code, which has examples of a very simple app that uses the different technologies that we'll be discussing. So if you want to follow along, go ahead and grab that source code, because I will be flipping through the source code examples fairly quickly. I don't really intend people to really just understand what we're looking at. It's just to give you an idea of what some of the technologies look like. So we're going to be reviewing a number of topics today: web storage, web SQL, IndexedDB, and so forth. So first of all, why do we need to be concerned about being able to store resources on a user device? Well, I live in Southwest Michigan, which is right there and surrounded by the Great Lakes. And zooming in a little bit farther, most of my time is spent in the outer areas, away from larger cities. So I'm at the very edge of an LTE network. So most of the time when I'm at like family or friends' homes, I'm on a very, very poor network connection, usually like 2 or 3 bars of edge. So I deal with slow and bad connections all the time. So what are some other examples of when our users may experience bad connections? Well, we have transit. I've noticed a couple times that when I'm on the train here, as I'm going through tunnels, I may get either a very poor connection or a very slow one. So rather than our users having to stop and do a breakdancing break, they could continue to use our sites. Now, since we do have the resident dancer here with us, do you have any breakdancing moves you want to show off? No? Okay. Sorry, everybody. Another example is network congestion. So let's say you go to a football game with 45,000 of your favorite friends, and so no cheers? Come on, this is Barry Sanders. He's like one of the greatest running backs of all time. No? All right, fine, let's do it your way. So let's say you're at a football game with 32,000 of your closest friends, and everybody has a cell phone. They're all hitting the towers. You may have a full signal, but you may not get any data whatsoever. So if you were able to store some of the data of something that you want to use on the phone itself, you could continue to use it even when you don't have a reliable connection. I had no idea who this guy was up until a couple weeks ago. Next one would be speed. So any resource that's stored on the device doesn't have to make a network connection and go out and grab something and bring it back. So you can save a lot of time and bandwidth by having the resources already on the device. And the last example is one that I run into quite a bit at the University of Notre Dame, and that's this statement, where we meet with a client and they tell us, we want an app. And they don't really know why they want an app, they just want an app. And so when we start discussing it, it's like, okay, do you want an iOS app? And they're like, yes, absolutely, we want an iOS app. And we're like, okay, well, approximately 30 to 50% of your users also have an Android, so you need to allocate resources to also create an Android app. And if you're going to have it on the Android store, you might also want to have it on the Amazon store. And then invariably, there's always at least 1 or 2 people, not usually more than that ruin it for everybody and have a Windows phone. He's right there, all right. So oftentimes, once you start discussing that with the client, they realize that maybe it's not an app that they really want. They just want an app-like experience. And that's something that we can do today with web technology. So up until this point, in the past, we had cookies. Cookie Monster. Now, the thing I love about this video is this woman here on the side really commits to it. She's like, oh, cookie. She's like very happy for him that he has a giant cookie. So cookies were introduced in 1994 by Netscape. Data is passed every time that the user hits a pass to the server. Does anybody by chance know how much you can store in a browser cookie? It's not a lot. Anybody want to take a guess? 4K. Very small, not a lot of data. Some less notable ones, Flash cookies, and we all know how Flash is going these days. And then Google Gears. Now, Google Gears was actually deprecated in favor of some of the technologies that we're going to be discussing today. And Charles, if I say anything wrong, you can correct me. So, the present. So, for examples, I mentioned that there's that repo on that page. You can go ahead and pull it down. I created a very simple to-do app. You can add items, you can remove items. It's just a matter of swapping out which JavaScript file you want to include, depending on which one you want to try out. Now, there's two things I want to point out here. This is what the app looked like when I created it. But then I got one of my designer friends involved, and he made it look much nicer. So the two things that I want to say about that is, one, developers, if you're making something that you're putting out in the wild for people to use, get a designer involved. They'll make you look a lot better. And designers, get involved in open source. GitHub and services like it are very easy to use, and developers like us will absolutely love you for contributing to open source and making our stuff look better. So if there's any designers, go ahead and get involved. So the first thing we're going to talk about is web storage. Web storage is one of my favorites. It's one of the most supported at this time. It's a simple API for storing either temporary or permanent data as strings on a device. Support is pretty good. You can see IE8 Plus is probably the oldest or the most recent browser. But we don't even hardly have any IE8 users at this point. So we can pretty much use it across the board. There's two different syntaxes, session storage and local storage, and we'll get into a little bit of a difference in that. Actually, let's do this at the moment. We're going to do a little quick demo about the difference between session storage and local storage. So let me pop over to browser. Bring this down a little bit. This screen's quite a bit smaller than my laptop screen. Okay, so you can see we're sitting at localhost right now, and you can come in and you can add an item. You can say foo, and you can add bar. Then you come over to session storage. So now we have two items on each one, session storage and local storage. Now we can refresh the page, data is still there. But if we switch over to another tab, which is the exact same page as what I have at the other one, it's just at a different URL here, and I hit refresh, we're not going to have any of that data because it is URL specific. But then another thing is if I take this page and take it exactly over here, you can see that the session storage data did not come along. Even though it's the exact same URL, session storage does not come along because session storage is specific to a tab or a session. Now, what's supposed to happen is when you close that tab, session storage is supposed to go away. But I don't know if you're familiar with Command-Shift-T in Chrome. It's very helpful, and it will try to bring, oh wait, was I on the wrong one? Here we go. So if I close this and then open it back up, Chrome is very helpful, and it brings back the session data. So that's something you might want to need to be aware of if you're doing something with high security. All right. So from here on out, I'm going to be using local storage as my syntax. Just know that at any point you can swap out session storage for local storage, and it's going to work. So first of all, testing support, it's pretty easy. You can just say, if it's not undefined, you have it, or you can use Modernizer. There's three different ways of setting and getting data out of web storage. You have the method set item, get item. You can do array syntax, or you can do object syntax that way. I tend to prefer the set item, get item. It just makes better visual sense to me, especially when you compare it to like removing an item or doing clear. It just seems a lot more straightforward. Now, I mentioned earlier, it's a key value store for storing strings. So if we were to say, for example, we put an integer of 500 into the value of foo, then when we pull it back out, we're going to get a string. So in that case, if you absolutely have to have an integer, then you need to parse it in order to have that string. Similar with objects and arrays, if you want to store it, you can, but you have to stringify it first and then parse it again when you pull it out. Now for storage limits are pretty decent. You can have between 5 and 10 megabytes before the browser will start asking the user to store more data, which is a much better than the 4K that you get with cookies. Now, as you're working on it, if you want to go in and see how things are looking, if you go to the Resources tab in Chrome, you can see right here, local storage and session storage. You can see that this is a list that I created on that Honeydew app, and it just shows the values that I've stored in a stringified array and dropped in there. And you can actually go in and you can double click that and edit it, remove it, delete it for debugging purposes. Some items of note. Clearing a browser cache will not clear web storage. So if someone goes in and does the typical clear my cache, it won't touch your web storage. It's fine. But there's also no built-in way to expire it, like you can with cookie. You can't say this is only good through such and such a date. You would have to also store something to say, like in your web storage, and then do manual checks to see if it's something that you want to expire or not. And also, like I showed in the example, it's scoped to the domain. So some quick examples. The New York Times uses a lot of web storage. If you go there and you go into the inspector, you'll see a ton of web storage stuff in there. That includes geolocation, browser info, ads, a whole bunch of stuff. Typically, you can store anything that you would store in a cookie, you can store in web storage, as long as you don't need access to it on the server side, it's fine. Smashing Magazine, they store web fonts. They base64 encode them and put them in there. The Guardian, they store visit counts, web fonts, ad displays, a bunch of stuff as well. So summary, local storage is a great way to store things that you need for quick access that you don't need to pull from the server every time. Web SQL database. So for the browsers that implemented it, essentially Web SQL was a wrapper around SQLite, which, do we have any Rails developers in the room? We have a couple. SQLite is what Rails uses for local development. It's actually pretty nice. But the support wasn't there for Web SQL. I learned some interesting stuff last night. Charles, one of the speakers here, was at dinner last night, and he gave me some actual background on what happened with Web SQL. So Chrome and Safari implemented in their browsers. Firefox and IE said, no, it's terrible, we hate it, we're not going to implement it. Is that right, essentially? And so at that point, the web specification group that was working on it killed it, and so it's no longer available. This is Charles. If you have any questions about that, you can ask him. So the fact that it's dead, and if you really, really liked the idea of having Web SQL available in the browser, blame Charles. He was there when they killed it. He's right there. And instead, the browsers were throwing their support behind something not quite as database-like as Web SQL, but it's called IndexedDB. And so what IndexedDB is it's a way of storing data that is transactional, but it's non-relational. But you can do searches and indexes on it. So it is pretty powerful in that sense. But what it's not is a relational database. Support is pretty decent. IE 10 added it, although not all of the features are there. One note about Safari and Safari on iOS, the version on iOS 8 is kind of broken, depending on how in-depth you go. If you're doing something very, very basic, you can use it. If you start getting into something more advanced, it has a bug where if you use the same ID in two different places, it will just start overwriting things, and it can cause big problems. So in that sense, it's functionally considered broken by a lot of people. To get into some of the syntax of IndexedDB, it's not the prettiest thing to work with. There's a lot that goes on when you're setting it up. This is the code that's in the repository, so we're not going to study this too much. But this is how you load data. You can add data, updating, deleting. It's a little verbose. But similar to web storage, you can go in and dig down into the Resources tab, IndexedDB, and you can view all of the values that you're working with. Or if you have a site that you're curious about, you can go in and see. Like if you go to checktwitter.com, you'll see an IndexedDB of all of your DM conversations. I don't know why they're there. If somebody wants to dig in and find out, that'd be great to know. And the reason that I brought up WebSQL earlier is if you take IndexedDB and you overlap it with WebSQL, you can get a lot better support going back to much older browsers. And you would do this by using something like these projects here. These are libraries that are built on top of IndexedDB and WebSQL to abstract the language a little bit, make it a little easier to work with. The one that we're going to look at specifically is LocalForge. They're the one at the bottom. It's a Mozilla project. And what they've done with LocalForge is try to create a library that works very similar to web storage, both in syntax and functionality, but it abstracts away a lot of the lines of code that you would have to write otherwise. And so when you configure this, you tell it which technologies you want to support. So you could say, I want to support WebSQL, IndexedDB, and local storage, or you could say, I don't want to support IndexedDB at all, and you just don't include it, and it won't even use it. One thing of note, I mentioned how IndexedDB is kind of broken on iOS 8. LocalForge actually returns false on an IndexedDB check for Safari because they pretty much consider that if you're using Safari, they're just going to force that device to use WebSQL anyway. So like I mentioned, adding items is very similar to the syntax of web storage. You can see you do a localforge.setItem, which is very similar. You're just using callbacks in this case, or anonymous functions. Get item, you can also iterate over things over the data that's in the storage. Deleting and clear, very similar. Just remove item and clear. Which brings us on to our last topic of the day. This would be App Cache. So, App Cache. So what this is it provides a way for you to list out resources that you want saved to a device for offline access. So that way, if you are on airplane mode, instead of getting like a blank page saying Safari can't open the page, you can continue to use it even if you're in airplane mode. So say I wanted to add some items to my to-do list. If I was in the air between the US and Switzerland, I could still go in, add some items while in airplane mode, and it would work fine. And App Cache support is also pretty decent. You can see IE10 Plus. Now, App Cache has kind of a spotty history. Going back to 2012, has anybody read this article? It's an older article by Jake Arch. It's he gives App Cache a really bad rap. And yes, there are good things and bad things about App Cache. As long as you understand the limitations of it, how it works, and when and where you should and should not use it, it's actually pretty nice. And so we're going to get into that a little bit. And this article is definitely worth a read, even though it's very, it can be definitely skew negative towards the technology. It still gives great insight into what it is and how it works. So getting started. The first thing you have to make sure you do is make sure that your server is serving up your app cache file, which is the list of all the files that you want to cache, in the correct format. So here you can see Apache, you can put this in your htaccess file to say that anything of .appcache gets served up with that type. If you don't, the browser will completely ignore it and it won't work. Now, .appcache is not like a required file extension for the manifest file. It's just a standard. that people have tended to adopt. Now, something that you do want to make sure, because there were some bugs in some browsers early on, is make sure that the app cache file is not cached. If it's cached by a browser, that means the user that downloaded that page is never going to see an update, like ever. So make sure that you set it so that it does not cache the files at all. Now, to actually start using it in your HTML, it's a simple matter of tagging on a link to the manifest file on your HTML tag. That can live anywhere on your site, doesn't really matter. You'll often see them at the root. And then when you start getting into the manifest file itself, it's just a matter, you have to have cache manifest as the first line in the text, and then you just start listing files that you want saved offline. And it doesn't have to be every file in your site, as long as you follow certain rules. And as you can see from the last one, they don't even have to be served from your server. They can be from a CDN if you need to. So looking at the honeydew manifest, which is the example, you can see that we have the cache manifest with a comment, and then the list of the files, and finally this network section is to say that anything that we're not listing, just assume that it can be used from, or just assume that it's available on the network, and don't worry about it. So some notes on domains. Resources do not have to be on the same domain to be cached, like I mentioned before. So if you are using a hosted version of like jQuery, you can still point to like Google's version or whatever. But if your app is being served over SSL, then the rest of your resources have to be on the same domain, and it respects same origin policy. As far as I know, Chrome is the only one that doesn't. Has that changed? Don't know. And actually, I think that Chrome has it right in that respect, considering how much that we're using CDNs these days. So like you have an app, you're going to have a lot of files maybe on AWS or Google CDN or whatever. I can see that that's probably the correct choice is what Chrome is doing. So we're going to dig through the structure a little bit. Like I mentioned, that has to be the first line of the file. Has to be there. The reason we have the comment there is the way that the app cache works is that unless that file changes, the browser will not pull down new resources. So it's nice to have a comment so that way whenever you update the site, you can just tweak that comment without actually changing any of the resources on the site. And the browser will know that there's some new content there. And I just typically use a date with a versioning number to make the change. Cache is the explicit section where you're listing all of the files that you want to be pulled down. Network, you'll probably just always use the star, is to say anything that I'm not listing here, just assume it's available on the network. And lastly, fallback is a way to point an existing resource to something else if they're offline. So an example here would be you have a file that generates dynamic content. Well, if they can't get to the server, it's not going to be able to generate that dynamic content. So you may want to point them to a static file instead. Or you can say that, you know, any images that I'm not listing previously, give them this fallback image. So the order that app cache works is probably the most important thing to understand so you don't pull your hair out during development. So the first thing that happens is you come to a site that has app cache enabled. The browser is first going to do what it always does. It's just going to download the resources that it needs, display them to the user. At that point, it's going to say, okay, here's the app cache file. Now I will start downloading all of the resources that are listed, which may or may not be files that you've already downloaded. At that point, when the visitor returns to the page, they are going to get the version served from app cache. So that, like, you go to the home page, you hit refresh, or so you go to the home page and something changes between their first and second visit, they're going to get the cached version. Even if they're online, they're going to get the app cache version. At that point, then the browser checks to see if the manifest has changed. If it has, it will download the new versions of those files. And then, when the next time the visitor comes, then it will show the new files. So there's the opportunity for files to be stale in the technical sense, but it'll still work if the user's offline. So some items of note, the referencing file will always be cached. So you have your index file or whatever, that has the link to the app cache file, there's no way, you don't have to list it because it's automatically going to be cached by app cache. And in fact, you can't even put that file in the network section and tell it not to cache it because it will just ignore it and cache it anyway. Also, like I mentioned before, the manifest file has to be updated in order for the browser to download new files. So you could, for instance, change every single file on your website, but if you don't update that app cache, the browser will not download anything new until that app cache file is changed in some way, even if it's just the comment. Also, if you have a file listed in your manifest and it cannot be found, like it results in a 404 or something, then the browser is going to consider that entire manifest file junk and throw it out and not use it. So that's something that you should be careful about. And like I mentioned before, cached files are always served from the manifest before it goes out and gets a new version, even when you're online, and that can be the frustrating part. Oh, and lastly, Chrome will not use the cache if the dev tools are open, which is a recent change. I was teaching a class last semester, and we were going over app cache, and I was like going through the example because I hadn't tested in a little while. I was giving an example. I'm like, okay, so we load up the page. Now we go make a change, and when I hit refresh, the change isn't going to be there. And the change was there. Because I had dev tools open, I didn't realize that they had made that switch. So if you're debugging and you need to make sure that it's serving up the right thing, close dev tools, make sure it looks right, you can pop them back open. But also, that's another thing, just not to pull your hair out, just be aware of. So some issues with responsive web design and app cache. So if we're building our sites correctly, you're not going to serve the same 2,000 pixel wide background image to all devices. You'll have, like for instance, a small, medium, and large, and depending on which breakpoint you're in, you're only going to show the small one or the medium one. So it's not downloading all three. Well, the problem with app cache is that you have to list all of the files that might be used. So let's say you're doing a manifest file by hand, and someone visits on a mobile phone, you still have to have the other ones listed because you don't know which device someone's coming on. So the user will load up the initial page that'll only download the small version, but then in the background, when it starts doing the app cache, it's going to download all of them. So that's just something to be aware of. That can be a little bit of a headache. Fonts. How many different fonts are in the typical web font stack? Somebody start listing off the different versions. We've got SVG, OpenType, TrueType, WAF, WAF2. You can have a lot of fonts in a font stack. So similar to the background images, if you wanted to make sure that you had full coverage, then you're going to be downloading a lot of different fonts into the app cache. So like taking a look at Google fonts, you typically only include this import file, and that's not the thing that's actually being fetched. It's actually pulling down some random long string version of a Google font, and it's going to depend on which browser you're on, which version you're going to get. So on the projects that I've typically worked on with that use app caches, I usually just do the WAF version because it has really decent global coverage. And then as long as you make sure that your font stack has a good fallback, like the secondary font is styled really well, yes, there's that 11% of users that may not get your pretty custom font, but that's okay, as long as you're styling up your fallback font as well. So the JavaScript side of app cache. There are some functionality that you can get into. Here's a list of things that you would see flashing by on your screen if you have DevTools open while you load up a site with app cache. You'll see that it's checking the app cache file, then it's downloading, and it'll show like 1 of 24, 2 of 24, and it'll just like cycle through. But the one that we're primarily going to look at right now is the update ready. That means that a new version has been downloaded and that update is now ready to be used. Because what you can then do is you can add an event listener to say that when an update is ready, rather than continuing to show stale content, you can give the user an option to load in new content. And how you do that's up to you. You can just force a complete refresh. It's just going to depend on what kind of site you're building. I would advise doing something like this rather than just forcing the refresh automatically, because the thing with App Cache is it happens in the background after the page is loaded, and it can take a little time, sometimes depending on the size, 12 seconds for the new App Cache to be ready to be used. And if your user is already interacting with the page and you just pop a refresh on them, it's going to be really frustrating because they could be in the middle of doing something. So this isn't technically related to App Cache, but it's something that might be useful if you're working on an app that could be offline at any point. You could use something like jQuery to switch a body class, so that way you can have different styles depending on whether they're on or offline. So you could show like your offline sort of notification. So it's just a little nice to have. Now, storage limits for App Cache are a little bit harder to get a hold of. You'll have some browsers where they say unlimited, or they'll give you a number, but it's really not that cut and dried. So this is just Chrome's documentation on storage limits. I'm not going to read this to you. The link is in the page, but essentially what it comes down to is that, let's say you have 5 pages or 5 apps on your phone that you've visited that all have App Cache. Well, those apps all share up to 50% of the free space on the device. So on the previous slide, you can see that it said unlimited or 10 megabytes or whatever. If there's only 2 megabytes free on the device, which with some of Apple's, I don't know why Apple still does 16 gigabyte phones. Those can get filled up pretty quick. So you never know how much free space is on the device. It could be a really small amount. So the devices share 50% of the free space and only 20% of the pool. So you never really know how much you're going to have. And then when the device actually starts running out of storage, the browser is going to start taking whatever the oldest app cache is and just start kicking it out. So if a user hasn't visited your site in several months and they have some newer ones, yours may be the one that gets destroyed. So you can't really be guaranteed that your app cache is going to remain on the device. And I would definitely not read this all to you because that's painful. So storage limits when it comes to app cache is really, I don't know, you never really can tell. So let's get into a couple of examples. So yes, this is not the right kind of football, I know. But football is very popular at Notre Dame. So this is a very simple page app that essentially shows the days, hours, minutes, and seconds until the next Notre Dame football game. Because Notre Dame football fans are that rabid about Notre Dame football. They want to know down to the second when the next game is coming up. So that's all this does, is it just counts down. It's a very simple one. So if you look at the manifest file, we've got a CSS file, JavaScript file, jQuery, a bunch of images, and that's it. So that way, it's always going to work well, and then when we need to update, we put in the win, loss, whatever. We just make a slight change to the comment in the app cache file, and it'll pull in the new version. And here you can see the actual progress in the console of the steps that go through. So you can see it's creating the manifest, and then it's checking the event, and 1 through 27. So that's typically what you can see. Now, similar to web storage and IndexedDB, you can go into the resources and view a site's app cache. The difference being is that you cannot edit this. You can view it, but you can't do anything to it. You can't delete it, you can't change it, at least in Chrome. The way you have to do that is you have to go to the URL chrome/appcache internals. And what you're going to get there is you're going to get a really long page, depending on how much web surfing you do, of all of the sites that you visited that are storing app cache on your device. At least for mine, it's a whole lot of Google Docs, because that's one of the things that we use a lot at work. So this is just the single entry for that countdown site. You can see that you can view it, you can delete it in case you're running into problems and you're debugging, you can just kill it. And it tells you when it was updated and whatnot. Another example, this is a website that I really like. It's called forecast.io. Is anyone familiar? Got a hand over there, we got a few. It's the same people that created the Dark Sky app, which is a weather app for iOS. I don't know if they have an Android version or not. But they use app cache in a very interesting way. So if you go to their website on your desktop, computer and view source, you'll see that in the app cache, so this is the, they have a separate desktop app cache and a mobile app cache. So I talked earlier about having to download all the different background sizes. They're getting around this by doing some server-side detection and serving up a different app cache file depending on the type of device that you're using. So you can see here that you have a desktop CSS, a desktop JavaScript file. You can see they're also storing a bunch of fonts. But then if you view the HTML file itself just by viewing source, you're going to see a whole lot of empty divs and spans because they're not using app cache in the strictest sense of working offline. They're using it as a storage device for all the files that don't change that often. And then they're using JavaScript to populate the content of the page. So they're getting the speed advantages of having all the files on the device without having to make those server trips. And then just layering on functionality on top of it, which is the only example that I've seen where someone's doing it this way, which I think is kind of clever. My last example would be a higher ed conference that I was involved in last year. Highedweb.org, it's a once-a-year large conference for higher ed institutions in the United States. So we created a responsive website for this conference that also included app cache. So first of all, why did we decide to do that? Because typically conference Wi-Fi sucks, especially if you're getting into much larger conferences. And also, instead of creating several native apps like we had in the past, there would be like an iOS app and an Android app and then the website. We decided to just go with a single responsive website that would work for everybody and work well offline. So very simply, we picked the pages that we thought were important. Schedule and the speakers were probably the most important ones in our opinion. Added in some files. We initially added all the images for the sponsors as well, but there were like, I guess almost 30 of them or something, so we are 28, so we decided not to include those in the app cache. Instead, we provided a fallback image, so that way we didn't have all these images getting downloaded and stored. And then obviously we included all of the CSS, the WAF file. Like I mentioned, we only included WAF. And then fallback pages. So there was a couple pages with forms, which obviously you can't log in and submit a form if you're offline. So we simply had a fallback page saying, we're really sorry, you're going to have to come back when you have internet connection to complete what you're trying to do. And then also, instead of doing a JavaScript pop-up when there was new content ready, we simply did a little slide down. So that way when there was a new version of the site, it just slid down and they could either choose yes or no, whether they wanted to reload it. A little less in your face, and it seemed to work really well. And we also use local storage to store all of the presentations that a user was going to go to. So this conference was actually, I believe, 8 tracks for 2 days. So it was an awful lot of presentations. So rather than sitting there and just scrolling and scrolling and scrolling on a mobile phone for what could seem like days, we gave the user the option to go into an edit mode and essentially select the ones that they were interested in. And then when they leave edit mode, it's a much shorter list. So they could easily scan through and see the ones that they actually wanted to attend. And then going back into edit mode, they could see all of them again and make changes if they wanted to. Now, one item of note about this conference, it's about 850 to 900, about 850 web geeks, all with multiple devices. I know myself, I had my laptop, my iPad, and my iPhone. That's a lot of devices hitting Wi-Fi if you take that average number and multiply by the number of attendees. So the first time that Wi-Fi went down at the conference president was on the website doing something, and she went to the homepage and noticed that the Twitter widget wasn't loading. So she sends a message out to all of us saying, hey, can you guys check on the homepage? Something's broken. The Twitter widget isn't displaying anything. We're like, that's right, because Wi-Fi is currently down. And she didn't even realize it because the site was working as it should. She could still get to the schedule, do everything that we needed to do. And in actuality, the Wi-Fi went down at least 3 or 4 times in a period of 2 days. Now, we do not still have App Cache turned on that version of the website, because the time that it was important was when you had all of those people hitting the Wi-Fi at one time, and we were concerned about Wi-Fi going down. So leading up to the site, no App Cache. Day the conference started, turn it on. Day it ended, turn it off. Because the before and after really weren't that important. Web storage, sure, that can stay, but App Cache didn't really need to be. So that's fitting the technology into the actual use case. Because typically a brochure site wouldn't need to have all of that. So what is the future of offline web technology? So there's a new tech called service workers. Its future is yet to be determined. Chrome is really on board with it. They're the only ones that have it like out in the wild for you to work with. I have not used it yet. It's something that I want to dig into. Safari, they're not saying, or Apple isn't saying anything about whether or not they're getting on board as far as I know. I love having you here, by the way. I can just keep pointing. Edge, Microsoft Edge, they're saying that they are interested and that they may add support. So maybe if Chrome and IE, if Firefox has it available behind a flag, you have to go in and enable it specifically. But it is available there. So hopefully if everybody gets on board, maybe Apple will get in gear. But this technology is going to provide a lot of functionality. Some of it would actually supplant a lot of the use cases for things like App Cache. So it's something to keep an eye on. Actually, if we go back, this link here, Jake Archibald, it's on the site. You can just go and click on it. I've included a section with resources for service workers. He has a really nice page that shows the status of all the things that are necessary for service workers to work well. And it shows who's supporting it and who's not. So wrapping up, web storage, small amounts of data that doesn't necessarily have to be passed to the server like you would with a cookie. IndexedDB local storage for larger sets, anything that needs to be indexable, searchable, whatnot. An app cache for storing files on a local device for offline use. And I'm hoping with some of the examples that I listed, it's to give you an idea of when and where things might be applicable. But the main thing I want you to take away from this is find a reason to play with these things. You may be sitting through this presentation going, well, I can never use that, or that doesn't make any sense for what I work on. But it's important as web developers. We're constantly learning new things, and we should keep up to date, even if it's just a passing knowledge of the different technology. Like the to-do list that I made. Find a pet project. Just try out these things just so you know what does, what doesn't work. So that way, if you have a project where one of them might, you'll know the pros and cons, the pitfalls of what it is that it can and can't do for you. So that's it. If you have any questions, feel free to hit me up. If your question is on service workers, my answer is I don't know, because I have not played with it yet. But I will soon. So thank you. It was pretty close to time.
Thanks, Eric. Yeah, you're like the best timed today, I have to say. Do we have questions?
Because if I don't know, he might.
Yes.
All right. So what you presented today were mostly examples where the user is consuming data. Mm-hmm. And I got to be honest, I kind of also expected this contributing data during offline state, which is synced automatically as soon as the user goes online again. Do you maybe have any frameworks you got experience with? So
I've not used frameworks, but I've just anecdotal. Okay, so he's asking about users storing data offline that can later be synced when they come online. That's definitely something you can do with these. It's just a matter of figuring out, because you're going to have to store something locally to say the last sync and somehow keep that in line with each other. And if you're an Apple user, you know syncing's hard because a lot of times things go wrong. But you could certainly store things either in web storage or IndexedDB quite easily and then have that sync to the server when you go back online. It's just I don't have any examples of that back-end code where you would actually try to figure out the differences between what's on the device and what's on the server. but they could all certainly be used to do that.
Other questions? No? Besides caching the manifest and storing too much, are there other like common mistakes or bad things that people do that you've noticed?
Not that I've noticed, because I haven't seen a lot of this in wide use yet. Web storage, if you just start leaving your console open and looking at web storage, you're going to see that there's a lot of sites using it. I'm not sure how I feel about the sites that store every single version of a font. I can see why, but it seems like that it's, like you mentioned, is pulling down a lot more data than necessarily has to. So that's why I'm looking forward to things like, you know, in the browser, being able to know if someone's like on roaming or has a bad connection, and being able to make smarter decisions based on actual device context. Because like if someone's on Wi-Fi, okay, maybe go ahead and pull down the extra fonts and store them. But if they're not, you don't want to necessarily start consuming their data plan by bringing down a bunch of stuff that they're never going to see or want or need.
Well, if there are no other questions, applause for Erik. Thank you very much.